500,000 lines of computer check proof. 5 of them redone in 24 hours by a model you can already rent. On Saturday, OpenAI published 10 new results in mathematics and theoretical computer science, and used them to name its next model, Astra. Every headline since has been about one number, $2,000. This episode is not about that number. Over the last 72 hours, a second story has been building underneath the first one. An audit. A mathematician at Anthropic reproduced half the results with a public model in a day. OpenAI's own researcher admitted the failures were never counted. And the proof repository itself, which we downloaded and measured line by line, says something nobody put in a press release. Let's go through all of it. Start with what actually happened and when. On Saturday, August 1st, OpenAI published a paper titled 10 Advances in Mathematics and Theoretical Computer Science, alongside a public code repository. We checked that repository's creation timestamp ourselves. August 1st, 6:10 in the morning, Universal Time. 10 results. Improved asymptotic upper bounds on sphere packing density, reaching the Cone-Elkies threshold. Exponentially stronger upper bounds for binary codes. A construction of a non-sofic group. A counterexample to Conus's rigidity conjecture. New lower bounds for computing the permanent. Exponential parallel repetition for quantum games. Hardness of approximation for the closest vector problem. Earhart's volume conjecture. And 3 Erdos problems. 146, 180, and 183. OpenAI's stated bar for inclusion was that no progress had been made on the main statement for at least a decade. The system behind them is called Astra, and here is the strange part of this release. Astra is not a product. It is an internal version of a model family OpenAI has not shipped, joining the names Sol, Terra, and Luna. No price, no release date, no benchmark table. OpenAI announced a model by publishing its output instead of its scores. And it made one more unusual choice. No human authors on the mathematics. The company wrote that claiming human authorship for a proof generated entirely by an AI system would misrepresent both the system's contribution and the nature of genuine human intellectual work. Its researchers say instead that they prepared the manuscripts, formalized the proofs, and take responsibility for their correctness. That caution is not accidental, because OpenAI has been here before and it went badly. In October 2025, a senior OpenAI executive, Kevin Weil, posted that GPT-5 had solved 10 OpenERDOS problems. Thomas Bloom, the mathematician who maintains the ERDOS problem database, pointed out the flaw within hours. A problem marked open on his site means he personally does not know of a solution, not that no solution exists. The model had found existing papers. While deleted the post, Demis Hassabis, who runs Google DeepMind, called it embarrassing. 9 months later, that same Thomas Bloom looked at the Astra results and called them big news, and rated them ahead of the unit distance counterexample OpenAI produced earlier this year. That is the strongest single signal in this story, and it is worth holding on to through everything that follows. Now the part that developed after the announcement, and it is the reason we are doing this episode. Within 24 hours, Levent Alpoch, a mathematician who works at Anthropic, posted that he had reproduced 5 of the 10 results. Not with Astra, with Claude Fable, a model that is already publicly available. His description of the setup was one line. Totally autonomous, generic prompt, no internet. By his account, the 5 included the arithmetic circuit complexity result, quantum parallel repetition, and the closest vector problem. His comment on OpenAI's write-up was pointed. He said he did not see much discussion of prompting in the announcement. Read that carefully, because it does not say the results are fake. It says something more awkward. If a shipping model gets halfway there in a day, the scarce ingredient may not be the model. That reframes the $2,000 number, which deserves a moment on its own. OpenAI's claim, in its own wording, is that the tokens used to generate all 10 solutions would have cost about $2,000 at Sol's interface rates. All 10 combined, though plenty of coverage this week printed it as $2,000 per problem, which is itself a sign of how thin the disclosure is. Gary Marcus, who has spent a decade arguing with this industry, called the release amazing but vastly oversold, and his central objection is structural rather than technical. If you pick 10 conjectures at random and solve all 10, that is extraordinary. If you attempt 50 and publish 10, that is a very different result carrying the same headline. OpenAI published a numerator without a denominator, and the $2,000 counts only the runs that worked. To OpenAI's credit, one of its own researchers closed part of that gap unprompted. Noam Brown, who leads much of the company's reasoning work, wrote publicly, "And yes, we did try other major problems without success. Sadly, no Millennium Prize problems, yet." He added that they did not spend a lot on each problem, and that it is possible to push test time compute much further. So the failures exist, they were acknowledged in public, and they were never quantified. Notice what traveled and what did not. The cost figure went around the world in a day. The admission of failure mostly stayed on the original post. That asymmetry is the real story of this week, and it is not unique to OpenAI. So let's do the thing most of the coverage has not done, and actually open the repository. It is called 10 Proofs. It carries an Apache 2.0 license, and it is written in Lean 4. We cloned it and counted 549,980 lines of Lean. The single largest file, the closest vector problem, is 130,430 lines by itself. The binary and spherical codes file is 114,000. The non-sofic group construction, the headline result answering a question open since Mikhail Gromov introduced soficity in 1999, takes 34,440 lines. 10 theorems. 500,000 lines of formal proof. The quality markers inside are real, and they are checkable by anyone. The project ships a manifest that reports a sorry count of 0. In Lean, sorry is the keyword that lets you assume a step you have not actually proved, so a count of 0 means no gaps were papered over. The manifest also lists every axiom each result depends on, and there are exactly 3: propositional extensionality, classical choice, and quotient soundness. Those are the standard 3 that ordinary formalized mathematics already rests on. No custom axiom was quietly added to make a theorem go through. It builds against Lean 4.32 and the MATLAB library. This is the part of the announcement that is not marketing. It either compiles or it does not, and you find out in minutes. OpenAI went one step further, and this detail has been almost entirely missed. The repository contains a directory of what it calls comparator challenges, configuration files that let an outsider recheck each result with an independent proof checker rather than trusting Lean's own kernel. The instructions name 3 external tools, including a separate implementation of the kernel and a sandbox to run it inside. In other words, the company anticipated the obvious objection that a machine checking a machine is circular and shipped the answer to it in the same commit. Whether anyone outside OpenAI has actually run those challenges is a different question. As of this recording, that repository has 418 stars, 38 forks, and 0 open issues. And there is one more line in that manifest that cuts against how this was received. Under prior work, it credits 2 community Lean projects on sphere packing, formalization efforts built by volunteers over years, for free. The Astra results did not appear out of nothing. They were formalized on top of MATLAB, a library thousands of people have been building for a decade, and in at least one case on top of somebody else's unpaid weekend project. The model is standing on an enormous amount of human infrastructure, and the file that says so is sitting in OpenAI's own repository, in plain text, where anybody can read it. Now the comparison that puts all of this in proportion, because a rival lab already published the exact number OpenAI withheld. In May, Google DeepMind released a system called AlphaProof Nexus. It attempted 353 Erdos problems and solved 9. That is a hit rate of roughly 2.5%, and DeepMind printed the denominator. It also reported 44 solutions out of 492 open conjectures from the online encyclopedia of integer sequences and settled a 15-year-old question about Hilbert functions in algebraic geometry. Cost, by its own account, a few $100s per problem. Same family of technique, same lean verification, and a published success rate. Terence Tao, arguably the most careful public voice on any of this, has been tracking that same figure independently. His assessment in January was that the true success rate on Erdo's problems is only a point or two, with the wins concentrated at the easy end, and no evidence that the median problem is within reach. By April, he was describing the field as moving from proof scarcity to proof abundance, with a culture and an infrastructure that have not adapted to it. And in June, he added the line that our 500,000 line count makes uncomfortably concrete. It is now easier to generate long correct proofs than short ones. As for the market, there is no clean read here, and we are not going to invent one. OpenAI is not publicly traded. Astra has no price and no ship date. For coordinates only, and from live data at Monday's close, Microsoft finished at $489.36, up 5.3% on the day. Alphabet at $375.36, up 5.4%. NVIDIA at $208.51, up 3.9%. The Philadelphia Semiconductor Index up 1.2%. Those moves belong to a different story running this week, the memory shortage, not to 10 theorems. Nothing here is investment advice. Look at how DeepMind's system was actually built, because it tells you where the competition really sits. AlphaProof Nexus is not one model. It is a framework with 4 agent variants. The simplest pairs Gemini 3.1 Pro with feedback from the Lean compiler and nothing else. The most equipped adds reinforcement learning from AlphaProof and an evolutionary component borrowed from AlphaEvolve. The interesting finding is that the simple variant works at all, which is the same lesson Alpoj's 24 hours points at, from the opposite direction. The frontier here may be the scaffolding, the harness, the prompt, the judgment about which problem to point the thing at, more than the weights themselves. And the third lab got there first, in a way most of this week's coverage has forgotten. On July 21st, Levent Alpoj, the same person who reproduced 5 Astra results a fortnight later, announced that Claude Fable 5 had disproved the Jacobian conjecture, posed by Ott Heinrich Keller in 1939 and open for 87 years. The counterexample was verified in Lean by the following morning. Kevin Buzzard of Imperial College London, one of the people who built the formalization movement, said this: "It is a big day. I think it's a great time to be alive, personally." Put the calendar together. May, Google, 9 out of 353, denominator published. July, an 87-year-old conjecture false. August 1st, 10 results, no denominator, a new model name attached. August 2nd, half of them reproduced. Here is what actually shifted, and it is not that mathematicians became obsolete. Finding a proof got cheap. Checking a proof got instant. That is what the Lean certificate buys you. Minutes instead of a referee's 6 months. What did not get cheaper is the step in between. Turning 500,000 lines of machine output into something a human can read, believe, and build the next theorem on top of. Tao has a name for the failure mode. Proof indigestion. True results arriving faster than the field can absorb them. If you want the leading indicator, it is the same trade that hit software engineering last year, when the bottleneck moved from writing code to reviewing it. Mathematics made that trip over a single weekend. The profession saw it coming and put it in writing. In June, an international group of mathematicians published the Leiden Declaration on Artificial Intelligence in Mathematics, out of a workshop at the Lawrence Center in Leiden. It is endorsed by the International Mathematical Union, and more than 1,000 people signed within 24 hours. Among its objections, that AI companies train on published papers without consent, and that they announce results by press release instead of peer review. Now hold that up against Saturday. OpenAI announced by press release. It also shipped machine-checkable certificates and an independent checker harness, which is a partial answer to exactly that complaint, delivered by the party being complained about. And there is a human cost that the people closest to it named directly. Uncle Matthew of the University of Chicago described this as a very rapid and very unsettling change, and specified who carries it, especially for junior mathematicians. That is the group whose next 5 years of work can be erased by a weekend run. Notice, too, what happened one day after the Astra release. Jacob Zimmerman, a 2026 Fields medalist, took leave from the University of Toronto to join OpenAI, not to do mathematics there, but to work on safety. Read that as one mathematician's forecast, filed with his own career. So what to watch? First, Astra itself. It is still unreleased and still unpriced. And under Executive Order 14409, the voluntary framework for how frontier developers engage with the federal government before release came due on August 1st, the same day as this announcement. If Astra ships, it is a plausible first test of that process. A model that just resolved 10 long open problems is a conspicuous place for a review framework to start, and how that goes will tell you far more about the next year than any benchmark table would. Second, and this is the one that settles it, watch the repository. The proofs are public, Apache licensed, and shipped with the tooling to check them independently. The remaining questions are mechanical. Does anyone outside OpenAI rebuild the 10 formalizations and report it? Do the comparator challenges get run by a third party? Do any issues get filed against those files? Because right now there are none. And separately, does anyone publish the denominator? Either OpenAI listing the problems it attempted and failed, or an outside group running the same harness against a fixed list and reporting the hit rate the way DeepMind did. Until one of those lands, the honest summary is short. The proofs look real. The success rate is unknown. That is the deep dive. 10 theorems, 549,000 lines of lean, 0 gaps, 3 standard axioms, and a denominator nobody has published. 5 of the 10 reproduced in a single day with a model anyone can rent. 2 other labs that already did versions of this in May and July. What OpenAI demonstrated on Saturday is real. What it did not demonstrate is how often it works. If you would rather have this kind of claim checked than repeated, subscribe. We go through the primary sources, the repositories, and the actual numbers every single day. Thanks for watching AI Daily.